Hey guys, welcome back to 4600. We're going to go over the recommended homework solutions for 8.8. So this will probably go pretty quickly because I only have a handful of slides. There's only 3 problems, so let's get to it. So exercise 8.81. The carapace links of 10 lobsters examined in a study of the infestation of the Thenus orientalis lobster by the 2 types of barnacles, Octolasmus tridens and O. loae, are given in the following table. So we've got the field, site, and then the length. So it's really just one sample. All right. Find a 95% confidence interval for the mean carapace length in millimeters of T. orientalis lobsters caught in the seas in the vicinity of Singapore. I think they would have told us that the early part of the problem, but okay. I didn't know it was going to be in Singapore. So example 8.1 here, we were given some information, like we know the sample size based on the number of values that are in that data set was 10, and that tells us the degrees of freedom, which is n-1 for a t distribution, is equal to 9. And the reason why we're using the t distribution is because I only have 10 values. It's way less than it's way smaller than 30, so we're going to assume this is a small sample size. That's why we're doing a T. All right. The confidence level they want us to do is 0.95, so a 95% confidence interval. I went ahead and calculated ahead of time y bar and the standard deviation because we're going to need those both. And the y bar for this group is 60.8, and the standard deviation for the sample was 7.969. All right. So that gives us that t sub alpha over 2 is going to be equal to 1 plus 0.95, or 1.95 divided by 2, and the degrees of freedom here would be 9. Oh yeah, this I'm using QT. And that's going to give us a value of 2.262. Alright, so we're just using the formula y bar plus or minus critical value t sub alpha over 2 s over the square root of n, which gives me 60.8 plus or minus 2.262 times the standard deviation, which is 7.969 divided by the sample size, which is the square root of the sample size, which is 10. All right, and that just equals 60.8 plus or minus 5.7. So, well, that's not my final answer. So my final answer should be the ends of the spectrum. So my 95% confidence interval I don't know why I spelled that out. I haven't been doing that all along. Confidence interval for u is equal to, the lower bound is going to be 55.1 and the upper bound is 66.5, and that's both in millimeters. So there's our final answer. So the next problem was 8.85, and this one says 2 new drugs were given to patients with hypertension. The first drug lowered the blood pressure of 16 patients an average of 11 points, with a standard deviation of 6 points. The second drug lowered the blood pressure of 20 other patients by an average of 12 points, with a standard deviation of 8. Determine a 95% confidence interval for the difference in the mean reductions in blood pressure, assuming that the measurements are normally distributed with equal variances. So they're telling us to use the pooled method here. And so that's what we've got to do. So we've got all the information we need. We don't have to do a lot of extra work here. But we know that n sub 1 is equal to 16, n sub 2 is equal to 20. We know that y bar 1 for the first drug group was 11 points, and y bar 2 was a 12-point reduction, and the standard deviation was for group 1 was 6, and for group 2 it was 8. All right. We also know that the confidence level they want is a 0.95. So the degrees of freedom for this 2 sample test is going to be n sub 1 plus n sub 2 minus 2. which just equals 16 plus 20 minus 2, which should equal 34 degrees of freedom. All right, and then that means T sub alpha over 2 is equal to QT of 1 plus 0.95 or 1.95 over 2 and 34 degrees of freedom, and that gives us a critical value of 2.032. All right, so we'll need that shortly. But we got to calculate the pooled standard, our variance first. So SP squared is n sub 1 minus 1 times s of 1 squared plus n sub 2 minus 1 times s sub 2 squared all over n1 plus n2 minus 2. So n1 minus 1 is 16 minus 1 gives us 15 for the degrees of freedom of group 1 times its variance, which is going to be 6 squared, plus n sub 2 minus 1 will be 20 minus 1, which gives us 19 times 8 squared. All right, we have to square the standard deviations in this problem. All divided by 34, which gives us a value of 51.647. And the square root of that for the pooled standard deviation is going to be equal to 7.187. So that's the pooled standard deviation we'll use in our formula. So now we can finally do everything. So we got y bar 1 minus y bar 2 plus or minus t sub alpha over 2 times the pooled standard deviation of the square root of 1 over n sub 1 plus 1 over n sub 2, which equals 11 minus 12, subtracting the y bars from one another, plus or minus 2.032 for the critical value, times this pooled standard deviation, which is 7.187. Let me make that a little better. 187 times the square root of 1 over the sample size of the first group is 16 plus 1 over 20 for the second group. And this gives us a -1 plus or minus. Multiply all that junk out after the plus or minus, and we should get 4.9. So our 95% confidence interval for mu sub 1 minus mu sub 2 is equal to -5.9 to 3.9. So, and those are points. We don't know whether, we just know they're points. All right, points in reduction. So there's really not a significant difference between either group since we went from negative to positive. So always recall that. So it doesn't look like either drug was significantly better at reducing over the other. And that kind of makes sense if you think about it. I mean, the average was 11 and 12. The standard errors weren't that drastically different from each other, or they're not standard errors, but the standard deviations of 6 and 8 weren't drastically that much different from one another. So we'd kind of almost expect this to happen. Usually when there's going to be a difference, you'll notice a grander difference between the y bar values or the standard deviation values. Sometimes, not always, but sometimes. Okay, for the last example, they've given us more information than we need. Let's suppose I only asked you to do part A, and I wanted you to do this using the Welch method rather than the pooled method. So, do SAT scores for high school students differ depending on the student's intended field of study? 15 students who intended to major in engineering were compared with 15 students intended to major in language and literature. Given in the accompanying table are the means and standard deviations of the scores on the verbal and mathematics portion of the SAT for the two groups of students. They want us to construct a 95% confidence interval for the difference in average verbal scores of students majoring in engineering and of those majoring in language and literature. Assume that the measurements are normally distributed with unequal variances, which tells us we're using the Welch method. So again, if I mention anything about equal or unequal variances, you can guarantee you're probably going to do a t interval differences between means, and do a t interval to do so. It'll just depend on which version you do, whether it says equal variances or unequal. All right, so let's get into that. So the information, they gave us a lot of information there, but they gave us the confidence level was 0.95. They love their 95% intervals in this book. I'm not sure why they stick to that the majority of the time, but they do. Y bar 1, and we're looking at specifically the average verbal scores. So we're looking at the verbal scores between the difference between the engineering and language literature majors. So we're looking at this part right here only. All right. So Y bar 1 equals 446. Standard deviation for that for the engineering group, I believe that was the engineering group, yep, is 42, and N sub 1 equals 15. Y bar 2 for the language folks is 534 was their average score, and S sub 2 was 45, with N sub 1 also being 15 because they took the same number of students in both groups. So remember, with this Welch group, we've got to figure out the degrees of freedom using the C equals formula and the degrees of freedom formula before we can ever find the critical value, T sub alpha over 2. So remember, C equals S sub 1 squared over N sub 1 divided by S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2. Okay. And here that's going to be, let's see, it's going to be 42 squared divided by 15 all over S sub 1 squared, 42 squared over 15 plus 45 squared over 15, which ends up getting us a value of like 0.465558. Alright, so not too bad. But the degrees of freedom formula, we got to use that value in there. So remember, that's N sub 1 minus 1 times N sub 2 minus 1 all over 1 minus C quantity squared times N sub 1 minus 1 plus C squared times N sub 2 minus 1. Alright, we'll do the denominator first because it's longer. So we get 1 minus 0.465558 squared times N1 minus 1, so N sub 1 was 15, so we'll do 14 here. As a matter of fact, both degrees of freedom will be the same for both groups separately, plus 0.465558 just squared times 14 all over 14 times 14, because that, and we end up getting 27.868. Alright, so that's our degrees of freedom, and the T alpha over 2 value should be QT or inverse T of 1 plus 0.95, or 1, I would say plus, and I want to write it 1.95 over 2 degrees of freedom, 27.868, and that should give you a number roughly 2.049. Now we got everything we need. We can finish this thing out. So we're going to do Y bar 1 sub 1 minus Y bar sub 2 plus or minus the critical value times the square root of S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2, which equals 446 minus 534 plus or minus the critical value was here, 2.049 times the square root of S1 squared would be 42 squared over N sub 1 15 plus 45 squared over N sub 2. I recommend double checking your calculations when you do these, whether you're going to use a calculator to do them, that's perfectly fine. I wouldn't expect anybody to do these by hand fully out, but double check your calculations, gang. So we get negative 88 for the difference in our means, plus or minus for the margin of error, the plus or minus part, we're going to get 32.95. So our 95% confidence interval for mu sub 1 minus mu sub 2 is equal to negative 120.95 to negative 55.05. And these are just points too because it's a test. All right, so that's where they differ. So obviously we can say, since both values are negative, what we could say if you were asked to interpret this a little bit, so we could say we're 95% confident. No, at the 95% confidence level, there's, or actually we can say we are 95% confident that the language, what was that group called again? Language/literature group outperformed the engineering group on the verbal portion of the SAT by at least 55.05 points and at most 120.95 points, is how we could interpret that. Because both values are negative, it means that the language literature majors outperformed the engineers on the verbal portion of the SAT. I'd be willing to bet the math portion goes the opposite direction if we were to find that one. So anyway, gang, that's it. This is pretty simple stuff here. It's just a matter of being careful with your plugging in the formulas and watching what I'm asking for. But I'd like to think most of you guys should be pretty good at this stuff. So I hope everybody's doing well, and we'll talk to you later. We've got one more to go.